Alright, here's the second part of Module 9. We are going to talk about area and perimeter of polygons. There is a lot of them. So here's all of the different types of polygons, plus one other, and we'll talk about that at the end. And here's all the formulas. Most of the formulas you probably already know, like rectangle, square, base times height. Parallelogram is also base times height. The biggest thing for a parallelogram is the height is not one of the sides. It's a perpendicular to the base. Triangle, you already know, 1/2 base times height. And then trapezoid is going to be 1/2 times the height times base 1 plus base 2. And then rhombus and kite have the same formula. It's going to be 1/2 times diagonal 1 times diagonal 2. And so I usually put these brackets on the side, just like how they have there, just so I know how to find the whole diagonal. So now let's just practice. So we are going to find the area. So if we look, you can do this a couple different ways. This is a parallelogram, so my area is base times height. So my base could either be 6, so then perpendicular to this base would have to be my 8. Now, some of you may not have seen that. You maybe have saw the 12 and the 4. 12 times 4. So actually, 6 times 8 is 48, and 12 times 4 is 48. So in this case, we have the same answer, which will be always the case if you have a base and a height. You won't always get both heights, though, in parallelograms. Alright, so now this one is a triangle. So I'm just going to do one triangle. You could do 2, but I think it's easier to do 1. So my base is all of this. So I need to add those up, and it's 66. So my area is 1/2 times 66, and then the height is 28. Oh. So I get 924 units squared. Alright, this one's a little trickier. We can split it up a couple different ways. I think it will probably be easier if I split it up into 3 different parts. So if I see a triangle there, I have a triangle over here, and then I have a parallelogram in the middle. So I want you to see if you can write down the 3 formulas and see if you can find all of the information. So I have the triangle over here is 1/2 times base times height. Well, that would be 8 times. Now, this length right here, I do not know. So that is have to be my x. This is 17, so over here is also 17. So now if I get something that looks like this, I can do Pythagorean theorem. So sometimes it's not as easy, just plugging numbers in. So I get x to be 15. So this is 15. So that is going to be my height. So 1/2 times 8 times 15 is going to be 60. So that's what that area is. And then my area of my parallelogram is going to be base times height. Well, 40 is my base because what is this height right here? It's not 17. We just found it as 15. So that's the tricky part because it's not 17. 17 is a side. You got to find the height. So that'd be 600. And then area of the last triangle is 1/2 times base, and then my height is still 15 because this right here is 15. So that would be 105. And now to find it all, so my area, you just add them all up. So if you split up your figure into multiple areas, then you just have to add them up. So it'd be 765 meters squared. And that is my total area. Alright, so we have a few more. Area of a rhombus. It says QT is 8. So I'll put that in, and then RT over here is 11. So now this is one thing we have to remember about rhombuses, that you have to make sure that you know some theorems. If you remember, the diagonals bisect each other. So I know that QT is the same as TS. So that's also 8. So my diagonal here is going to be 16. My diagonal down here is going to be 22. Well, now when I plug it into my formula, 1/2 times D1 times D2, 16 times 22. I get 176 centimeters squared. So that was a little tricky because you had to remember that the diagonals bisected each other. So I want you to do the next 3. The bottom one is the easiest one. The top 2 are going to be a little bit trickier, but I want to see if you can figure those out. Finding the areas, and then we will talk about how I set them up and solved. Okay, so let's talk about the first one. I made it into one figure of a trapezoid. You can do 3 different ones of a triangle, parallelogram, triangle, and you will get the same exact answer. I just think a trapezoid is easier if you can put it all together. Your height is 23 because it's the distance from one base to the other. So that's 23, and my 2 bases, since the middle is a parallelogram, I know my sides are going to be, opposite sides are congruent. So that's how I knew that was 32, and then I just added everything up at the bottom. And then I plunged in my calculator and I got 1,219. The next one is a little bit trickier because you needed to find 2 different areas, the rectangle and the triangle, and then you had to subtract the 2. So you had to find the whole piece, and whenever you have a white piece in the middle and it's being punched out, you have to subtract it. So for this case, I needed to find the area of the triangle. Well, the rectangle was just base times height, which I had both. Here I needed 1/2 base times height. So 1/2 base times height would be, it's a right triangle, so I needed my 2 legs. Well, I only had 1 leg and the hypotenuse because I knew that the top was 34 as well. So that's why I had to do down here, I needed to do the Pythagorean theorem in order to find my other side, because then I could do 1/2 base times my height to get 240. and then I subtracted to find my total area. The trapezoid down here, 1/2, my height was 10, my one base was 12, my other base was 6. So this one was very simple, straightforward. You had everything you needed. You just had to know the shape and the formula, and then you were done. Alright, we have one last part, and that is going to be a regular polygon. So it could be a hexagon, octagon, pentagon, dodecagon. It could be a lot of different polygons. A few of the vocab words. The center is the center of the circumscribed circle, which just means the circle around it. The radius is from the center to the edge, so it's to a vertice. And then the apothem is perpendicular to one of the sides. So that is what we want. We'll talk about that. And this is my radius, and that's my apothem. Distance from the center to any side of the polygon. From the center to any side that's perpendicular. So that's going to be my apothem. In order to find these, we are going to actually just do the triangle formula. Then we don't have to memorize a new formula and all of that. We're going to split this hexagon into 6 triangles. So if I just draw, there we go. So I have 6 triangles. Now, so my area, I have 6 of them, 6, and then it's going to be 1/2 base times height. So my formula, actually, maybe I should write out the formula first. So that's going to be the number of triangles, which is also the number of sides. So a hexagon has 6 sides, it also has 6 triangles. 1/2 times base times height, because that's the area of a triangle. So now I have 6, 1/2, and then my base is this right here. Well, over here it says it's 11. So 11 is my side length. My apothem, which is the height of the triangle, is 7. So there is my formula. So it actually turns out very simple when you split it up into triangles. So I get 231 centimeters squared. So see if you guys can find the area of this wood piece, and it is a regular octagon. So see if you can use this formula and set up the formula and find the area. Alright, so if I take the number of triangles, which is 8, times 1/2, and then my base would be the side length, which is 5.812. That's what it said up here. And then an apothem of 4. So I put in my apothem, that's the blue line. It's the height of the triangle. And now I just plug all that in my calculator and get 92.92. Alright, so that is all about areas of polygons. You can do some practice, try it on your own. The answer keys are there, and then you have a quiz.